Welcome, everyone. Okay, so I know a large fraction of you, but just wanted to introduce myself, Renato Bonomini here. I handle sales engineering, and this used to be a nice joke when I used to live in Boston, and then I moved to LA, and people asking, "Oh, where is that accent from?" I'm from Boston, obviously not from Boston. Yeah, it doesn't work over here, so that's okay. I do live in Los Angeles, so my weird accent comes from that, even if I spend an awful amount of time here in Milan. And I've been with the company quite enough. I'm looking at that gentleman right there who actually did my hiring back in the day. So, yeah, you can tell my age. Yep, it happened. That's why I had to move across the ocean so that he doesn't check on me every 5 seconds. Yep. When we were working, Matteo, on the agenda, I really pushed forward the idea of doing a morning where we do how-tos. So session learns on how to do things. So this first one is about building a voice agent. Now, Elias earlier talked about why LLMs are important for personalization, what's the goal, recommendations, and so on. So what I want to focus also, what are the key differences in actually have voice interactions? Because there's a clear difference between a chat when you can actually type and wait, or your experience is using ChatGPT and you ask a question, you get the responses, or whether you're a cloud person or ChatGPT, or Grok, or Olama, whatever preferences, and if you're talking to something. Now, I think we all have been in a situation where you thought it was pretty awkward to talk to your TV, right? So it's definitely, you're trying to speak to the microphone, to the remote control, it is really an awkward feeling. So with the power given by LLM, text-to-speech, it's now becoming something that it's actually effective. But there are some lessons learned that are important to make it effective that are different from using LLMs and generative AI in general. First thing, so what is this workshop about and what it's not? So I'm going to give some things for granted, and I'm going to tell you which ones they are. So if you want to ask questions and get a little bit of reflection on why, we can do that. So the most important point, what the workshop is, why you actually need a brain behind the LLM. Everyone thinks, oh, the LLM are great. They know the reason, they have information. Yes, but they are extremely unaware of you as a person and your content catalog as a provider. So you need to give that information back to them. Some selection guidelines on how to choose, for example, one model versus another. What are the important key factors? And this will be provided as sharing lessons learned, and also something that I learned based on what my mother taught. I'm Italian, so mother is obviously pretty important. What this is not about, UX Engine internal, so APIs and so on. If you're interested, I'm more than happy. That will take more than 20 minutes or half hour. It will probably take a full day. I'm looking at Rasha and Roberto right there. They do know that they need to stop me when we start talking about technical things, yes. This is not an off-the-shelf product. Oh, can we have it tomorrow? This is more, what I'm going to show you, it's more of a working prototype, working framework. The idea is to show you what it can be done, and pretty soon you'll see that a lot of these are PCs. And I'm going to point out which pieces you can buy, license, make, have it run in your cloud, and so on. I'm not going to answer the question, will AI replace recommendation engines? Now, you can all turn around and look at Paolo Cremonesi right there, who's hiding behind the pillar, right? And he can give you a really nice convincing reason on why recommendation engine and LLMs needs to work together, right? Rather than be replacing each other. So here it will be even more important, and we'll see why. Now, and in general, is AI overhyped? Now, I tend to be pretty strict around machine learning, generative AI. I hate when someone just throws the word AI in general, even if we're probably going to say it 1,000 times today. So yes, it is overhyped from my perspective in general, but this is actually one of the premium applications, voice agents, when the effect of generative AI really makes a huge difference. Very simply, let's go through the mechanics of running a voice agent, specifically for a media entertainment and streaming application, but this is in general, but we're going to focus specifically on this. So very simply, you are a user, you make a query through your voice. First thing that happens, it goes through what we call a speech to text. That's pretty much what happens everywhere. Now, with the exception of newer models which are voice native, there are some models that have been developed that do not need a speech-to-text translation layer, which will make it text. Pretty much the majority of systems out there do a first layer of translation of taking a voice and in real time translating to an actual text so that to the LLM itself, it looks like a chat. The LLM doesn't know that you're actually asking voice. That's the first layer. Why do we want to keep it separate? We'll come to that in a second. At that point, the speech-to-text goes to the LLM itself, which talks to UX Engine, and we're going to see why it's important that it talks to UX Engine as a content brain. And UX Engine provides the context and the grounding. We'll talk about those two problems, which are fundamental in why this makes a difference. You can take UX Engine out of the equation here. Yes, absolutely. You can do that. But what happens is that the LLM will make up answers. You can go and ChatGPT right now and say, hey, what should I watch now? It will give you an answer right away. Does it make sense? It looks perfect. It makes no sense, absolutely. So it'll make things up, hallucinations, right? So that's why we have UX Engine right there. And it doesn't know anything about you. Yes, well, we have memories in agents, absolutely. But think of a service when someone comes in and has your viewing history. So that's what's available in terms of context. So exchange goes, user speaks, goes through speech-to-text, goes to the LLM talks back and forth with UX Engine, gets it back to the text-to-speech layer at that point, TTS sections, and gets back to the user, which actually gets a response. Like, hey, show me something funny. Here's some funny movies for you. This whole layers needs to happen very quickly, because it's really annoying if you ask something. Here's the answer. That's really annoying, right? So it's a very upsetting experience when there is more than 200, 300 milliseconds delay between your question and the answer. That's why a lot of voice agents add additional features, such, for example, as clicking noises. You might have used like one of those virtual interfaces where you ask a question and you hear click, click, click. Obviously, the LLM is not clicking, right? It's making noises up so that it keeps you entertained. You think something is happening while it's just thinking. So it's important that those layers happen in a short amount of time. That's critical, and we'll get to why that's critical in a second as well. I want to focus a second on the layers in between, because obviously, you've probably seen you are in the ContentWise offices, yes, so UX Engine is centric, okay. And the user is obviously, user is king. But what's in the middle? From my perspective here, what's in the middle is literally a commodity. Speech-to-text, text-to-speech, there are thousands of solutions out there. Some are better, some are worse. There's so much choice. LLMs, well, every day a software engineer wakes up and there's a new LLM on the field to be tested. So there are plenty of LLMs. So how do we choose which one? I'm not going to go through text-to-speech or speak-to-text, but I'm going to focus a second on a couple of icons that you see in the middle. So you can buy these as SaaS solutions. You can license them. You can build them. I'm talking about speech-to-text. Speech-to-text has been around for quite some time. So there are very mature solutions out there. So the solution here is pick whatever you want. They really just work. They're equally good. As long as they have a short amount of time for response time, they're pretty much all the same. So we are literally treating that as a commodity. Sure, the example that I show you, it's based on 11 Labs, just because it's a quick tool to make prototypes. And it has a lot of emotions in voice and so on. But do you really need your TV to be emotional when it tells you back the story? Oh, here's some sad movies for you, right? It's not really needed. So a lot of those features are really not required. Any additional features adds complexity, cost, latency. So you really need to be careful to keep things as simple as possible. Now, when it comes to LLM, once again, you can build your own LLM. Nowadays, nobody does that for a good reason. Or you can run it in your own environment. You can run a commercial one. And that's what I wanted to take a look at a second in how to select specifically the LLM portion. There are three things that we want to look at. The reasoning part, how well LLM can reason given the context, the catalog information, the ability to provide back a response. What does something funny actually means? Oh, it means that you're looking for movies or content that has a funny mood. Okay, you're not asking the agent, show me all movies where actor is equal Tom Cruise. That's not the kind of experience that you want. So the reasoning part is the ability for the LLM to understand a query. In this case, yes, it's a voice query, but it gets translated into an actual text, into something that the machine understands. That's what we're looking for, enough reasoning to translate a very short, brief message into something that makes sense. Or maybe a kid is screaming in the background, or maybe a plane flies by and there's noise. So you want to make that reasoning strong enough so that it takes that information and it looks backwards to UX Engine and asks for the content information. The second part is what we call latency. The latency portion is what I was mentioning earlier. Now, by virtue of actually trade and education, I'm a telecommunication engineer. There is a law in telecommunication, it's called the Zipf's law, which says that if you cannot have a conversation that has less than 250 milliseconds response time between back and forth, it's going to feel unnatural. So that's very important. You all have a mobile phone. Mobile phone use global system mobile phones communication, GSMs. And GSM's codification codecs that are in place, which are extremely complex, have been designed to keep latency between 250 milliseconds. The first people that started using it notices a little bit of delay. Now you're used to it, but that's actually a fundamental part of that. So latency here is even more important. If you have 1 second between the query and the response, literally, it's going to be a very bad experience. Now, we all wish that cost was not a concern or a guideline or something that we have to look at, but let's face it, and I'm looking at all of you, we are in a reality of media entertainment where, yes, cost is a big factor. No, we're being crunched into doing more with less and being more effective and sell more ads and make sure that we can reduce churn. It's all about making sure that we can hit the bottom line, or there is literally, and I don't think I'm saying anything new to you, it's literally about survival of streaming services at this point. So cost is the biggest factor. There are 2 orders of magnitude of difference between cost in very simple LLMs to what you're currently using. For example, let's say you are a cloud user and you use we should test Opus 4.8 because it's so cool, it's so powerful. Yes, it only costs you 500 times more per query. And we're talking about, I did a math exercise once for a US operator who asked to evaluate building a voice agent for their subscription service, and that's about 10 million users. And when we came back, well, it's only going to cost you $10 million a month to operate it. They said, maybe we'll do it some other time. So cost is really fundamental here. It can become astronomical. Good news is that latency and cost, good or bad, latency and cost are tied to each other. So why is that? Latency of a LLM is, and I'm talking technical term, if you're familiar, inference, that's how LLMs work. They infer something from a query. So the cost of inference is directly related to the actual cost of running the LLM itself. So if you get a LLM that has a lot higher latency, usually comes a higher cost. So you want to have something which is pretty economical, and usually the smaller ones have a smaller latency too, usually. The reason in part as an effect as well. Let's look at some numbers just to get an idea. And here I'm comparing commonly available off-the-shelf market LLMs that are in place. We start from the premium ones. Here, this was done a few days ago before Opus 4.8 was out. GPT 5.5, 4.8, latency of average. These are absolutely average latencies. You need to include network, where you are, the complexity of the query. So this could be 50% plus or minus. But in general, 1 to 2 seconds. You can already see you ask something and just the LLM portion takes a second to go back. So that's just not something that you can actually do. I'm not going to go through every single one of them. I just wanted to jump to the last one. Latency tuned Qwen 3.6. For those who are familiar with LLMs, Qwen is actually kind of an open source, open weight LLM. You can actually install it in your laptop if you want to. It's not commercial. It's kind of open weight, so everyone can use it. You can install it locally on your device, in your environment. Extremely simple. So that's 35 billion parameters. So it's one of the smallest models you can run. A smaller one will be Gemma 4, recently released. So those are extremely small large language models. The difference will be that if you work on an Opus 4.7, for example, it will be capable of understanding very fine or granular details in descriptions, while a model like Qwen 3.6 might be a little rough on the edges. So it can kind of absolutely every single shade of gray, black or white. That's the kind of difference that you get in response from each one of them. But let's look at the good news. Latency, 200 milliseconds, 233, and look at the difference in cost. That's an enormous amount of difference in cost per transaction, okay? So you have to actually look at that. And at the end of the day, what might be driving is you need a certain latency, and then you find out that it costs so much. As much as for this example, that's what we're using, Qwen 3.6. I tested with all of them. You hardly notice the difference in the responses, in the quality. They're pretty much all the same. There are very few cases where a larger model will actually give you a better or a more effective response. So a model like this is plentiful. And why is that? Well, this costs a fortune. Okay, so what do? And I have to find a reason to use Austin Powers Mimi every time I do a presentation, so especially this one, like it. So, well, let's just have it run on the end user device. If you have a recent phone, whether it's Android or an iPhone, you likely have a neural chip or an AI chip or however it's marketed, which is literally a small GPU designed to run LLMs locally. Apple started with the A15 and A16 now and A17 and so on. They all have an internal capability to run LLMs locally. You might be familiar with Apple Siri Intelligence. There is a future coming where if you are a company that actually provides end-user devices, it's even easier, like a set-top box, or there will be a future very soon where you can install an app that has control over the onboard LLM machine engine, and you can run it locally. So at that point, the cost part is no longer a problem for you as an operator, and the latency is much lower because it's running locally. It's not so much about privacy. That's one concern. But I live in the US, so privacy doesn't exist, right? So that's why it's not here. But definitely cost is a big factor, and hopefully, originally we were going to have Fabio in the afternoon, Fabio Violante, who is one of our founders, who was the CEO of Arduino, now acquired by Qualcomm, talking about edge LLMs. That was the whole idea. Unfortunately, he's held up in a board of directors meeting, so I don't think he'll make it. That's why the long queue to talk about on-device LLM execution. The TTS and STT, text-to-speech, speech-to-text, those have been running forever on devices. So anytime you talk to your phone, it's 99% of the time not going back to the cloud. It's being processed locally. So that's already possible. So you take out all the latency, all the cost by running those three elements. Let me go back here. So these layers, as you can see, well, you can buy it SaaS, you can license it, you can run it on a device, whatever does the trick. As long as it's quick enough and it doesn't bank wrap to you from a licensing perspective. All right. So I want you to take a look at these 4 things as soon as we get started. Now I'll show a little demo here. Hopefully it usually works. Context. So what's context? Context literally here is in the context of LLM context. So we need to inform the LLM of what the user profile is. Because if you start a conversation with LLM and ask for anything, it will give you a response, but it doesn't really know who you are. So this is sometimes called memory, but really it's what's called context. So the first thing that we do, the agent knows about you. And where does that information comes from? Well, a lot of you do have UX Engine running in your environment. Well, guess what? UX Engine knows about you as a user. It knows your preferences, what you watch, what you like, what you thumbs up, thumbs down, your packages, all the information that we usually use for personalization. That's a great context. Don't try to make it up again. It's already available. It's right there. So we make that context available to the DLM to start a conversation with informed opinion about the user. The agent knows me specifically. Second thing is ground. Now, you can ask ChatGPT for recommendation again, and it will give you a list of movies, and good luck having those movies in your service because it knows movies that are available in general out there. So very rarely you will get your catalog. Oh, I can pass my catalog as part of the context. There are technical limitations in context size. This is another key factor in choosing an LLM, the size of the context window. The larger context window you have available in LLM, the more it costs, the slower it is. So we want to keep the context small. Why do we want to pass the context, the whole catalog to the LLM? We have a search service. UX Engine knows exactly what content you have in place or your CMS. So why should we let the LLM make up movies that you might not have? We know exactly what's available. So let's use grounding to make sure that we inform the LLM about exactly what the user is about and exactly what the content is about. How does the LLM and UX Engine conversation goes? It goes through tools. Now, Ilias earlier talked about MCP, and I'll show you why tools versus MCP, and most importantly, speed. So for example, now give me a second, I'm going to switch again. And if you have any question in the meantime, please go ahead while I do one thing here. All right, most of you might be familiar. This is the UX Engine UI simulator where you can pretend to be a user or a made-up service, and you can see how things work. So we're just going to connect the user Jack, and we're going to start a voice conversation.
Hi, Jack. I'm here to help you find something great to watch. Tell me what you're in the mood for.
Something funny.
I have some great funny picks for you.
No.
Thor, Ragnarok is a hilarious superhero adventure where Thor faces off against the Hulk in a gladiatorial contest. Father of the Bride is a classic comedy about a father.
Now, here you can decide how much explanation you want, how many items you want. This is not UX Engine itself. This is the LLM, and I muted it, so it's not going to complain that I don't talk to him. It's like, hey, did you leave me here? Let's leave it do that. So this is actually, this explanation comes from the LLM itself. Not now. Oh, yeah. Okay, let me restart it so that we get it up and running again.
Jack, I'm here to help you find something great to watch. Tell me what you're in the mood for.
Science fiction. Now, the question is very generic, very broad. Now, I could make, hey, I'm feeling sad. Can you show me something that cheers me up?
Great science fiction picks for you.
So the explanation here comes from the LLM itself. Explanations are a great way to use LLMs because we ground information out of the UX Engine, we provide it back to the LLM, and the LLM makes up an explanation which is very readable in a way that it's actually nice. And it's not just list of movies, right? The usual experience would be recommended for you, list of movies, and don't really know what the movies are. Here it actually explains you. And it also tells you why those things are being displayed to you. So let's do that. Why would I like Jurassic Park?
Jurassic Park, because it is directed by Steven Spielberg, who is one of your favorite directors, and it stars Jeff Goldblum, an actor you have watched frequently. The film delivers the thrilling and intense experience that matches your viewing preferences perfectly.
All right, so now let me go back here. I took an hypothetical conversation here, and I'm going to explain step by step what happened. So we start with, hey, what you're in the mood for? It can be mood, it can be show me something short, a generic query. The first thing that happens is, actually before that happens, the UX Engine provides the context to the agent. So the agent already knows that user Jack is there. You might have noticed that user Jack the name was mentioned. They don't make it up, it's actually the username. And the context about the user is actually provided. User asks for something, and this is where we start introducing tools. Tools are the options available to LLMs to query another system. And what the LLM does is, hey, the user is asking for something. I understood the query, so I'm going to do a search query. And since it's a search query for a user, I'm actually going to personalize the responses. So the search is simply mood is funny, and that's a technical search. Why does the LLM know that it needs to ask for that specific value, funny, in that specific field, moods array? Because that's also part of the context. When the conversation starts, the actual toolkit here provides back to the LLM, these are the metadata fields that we have, and these are the values that you can query against. So no more guessing about, hey, post-apocalyptic movies. Sorry, there's no post-apocalyptic. Sure, you do not have post-apocalyptic movies as a genre. But the LLM knows that, and it will change the query to find something that is related to. So the semantic part of LLMs here comes into place. Agent comes back with an answer, and as you can see, it goes back and forth. Explanations are grounded in the user profile. So you saw earlier that, hey, you might like this because that actor is in there, and I know you watch movies with that actor, and you often watch this kind of content. So the explanation itself is grounded on the actual user profile. There are other tools available that could be used, for example, related titles. Now, the network here is not great, so there was a little bit of latency, and I'm also running an environment which is set in the US, so we were going across the ocean with this. So latency here was not great, but you see how it's important to actually have a back and forth that is fundamental. So if I were using a much larger model across the states and everything, it would be awful. Not in this case. Yes. Yeah, it's a choice, correct. So this was specifically a choice that I make in this demo where instead of relying on semantic search, I'm relying on standard search, and I'm letting the LLM do the semantic translation. LLMs are great at doing semantic translation. So if I ask LLM for something, it will be able to translate in other terms. That's the semantic portion. So I don't need semantic search here because the LLM itself does semantic on its own. If I did not have an LLM, then it could work. Now, you can still use semantic search behind the scenes. I just decided that I wanted to give the LLM, these are the metadata fields you have. These are the values you can query against. So show me exactly that information. This is also helpful. For example, show me short movies. It will look at runtime and it will ask for any content which is less than 30 seconds. Show me recent movies. Semantically, that really never works very well. So if we go directly to the actual data and filter on the data, sometimes it's more precise. So my decision here was to use the standard search, which cannot be also personalized. That was important. And not rely on semantic, and let semantic be handled by the LLM itself. So there are really only 6 tools implemented here, which are pretty much everything that you need to do to actually implement a voice agent. And you can see here a pattern already. Some of these are asking the recommendation engine to perform standard things that you always do. Give me a list of recommended items for the user. So the user context is already available. So this will be your usually recommended for you. So the LLM can go and ask the recommendation engine for a good set of recommendations. Get related titles. Instead of asking the LLM to find similar content, and it will try to do keyword matching, which is, yes, it works, but it's extremely poor. You can actually use the built-in features that are already available. Search content, which is pretty powerful, so we can use it. Get user profile. We inform the agent about everything related to the user. Get metadata values. What are the fields we can query? What are the values? And get item details. How did the LLM know that that movie has those actors, those genres? You cannot rely on the LLM to have that information built in. If you're using Opus 4.8, a million with an LLM model with, let's say, 500 billion parameters, maybe it knows about Hollywood blockbusters. It's not going to know about your specific local content. It will not. And also, you usually want to recommend recent content. It's never going to be available in the LLM itself. So we need to provide to the LLM an explanation of what the content is about, which, for those of you familiar with UX Engine APIs, that's simply a get item detail call. So let's just use UX Engine and ask about it. So what problems do we need to face when we are building voice agents? This is for agents in general, hallucinations. Sure, I know that we talked about this several times. You can go on ChatGPT, you can ask for recommendations, and it will provide you recommendations. Those are rack hallucinations. It's a made-up word, which means really, yes, it's just throwing titles at you, but they don't mean really anything. So what we want to do is we want to ground the catalog, and we want to ground the user profile. We have that information in UX Engine. Let's use it. Problem number 2 is trying to use LLMs as Swift knives. LLMs are great at explanations, building phrases, putting together information, semantic search. They're not prediction models. They're not forecasting engines. They're not linear regression models. They can pretend to be, it can look very convincing, but in reality, they're not. So use traditional recommendation engines, which are very powerful, dedicated algorithms to do the prediction part. The output is raw, it's technical, it's a list of items, and then ask the LLM to explain why. So use the power of traditional recommendation engines which are designed for a specific goal, and let the LLM do the talking. Last problem is shifting editorial needs. I think we've all been there, where when you're running a service and the marketing team comes in and they change idea every other hour, right? What are you going to do? You're going to change a prompt every time in your LLMs. Oh, we need to prioritize our own content. And then every hour, that kind of rules change. If you use the UX Engine, you might be familiar with business rules. So the idea is, well, once again, if you rely on the UX Engine as the content brain behind an LLM, you can also use those business rules as a way to avoid having to change the configuration of the agent. Literally, the agent that you see in this example has been, the prompt has been developed once, and I never change it. We use the same prompt across different demo environment, and also we have partners that are using it in their pilot systems, and it's the same prompt for everyone. We don't even need to tell what environment it's running on. There's no local information that needs to be changed every day. Very important is that the prompt is the fundamental part of building up the agent. So you explain to the prompt how it should handle user queries. So for example, if I ask, show me something funny, I did notice that the lower reasoning agents are not as smart as the highest reasoning agent. That's what happens when you use a lower tier model. It's not as intelligent, right? When you ask, show me something funny, it can't really understand whether do you want to get a recommendation or do you want to search. It's not that intelligent. So you can make up for that choice of using let's say one of the less reasoning capable models with just building a better prompt. So this is an example where I was literally debating whether to use a more intelligent model, and I just realized, well, let's just make a better prompt. So let's just explain to the agent how to deal with things. And how are we doing timing? I'm just going to tell a little story, unless Matteo tells me that it's absolutely time to cut it out. So this will probably give out my age. I'm 1976. Let's get that out and clear, okay? So I used to burn CDs. You probably have back in the days, right? So one day I was going out with my friends and I asked my mom, who is absolutely computer illiterate, hey mom, when a window comes up on my computer, I was burning, just press OK and something will pop up, you just plug in another CD and you're good to go. So I go out, have fun, come back and expect a dozen of CDs being burned and we're all happy, I can share music with everyone. And my mother goes, oh, I wasn't able to move the mouse pointer. She didn't call it like that, but and it kept moving around, and I was like, gosh, mom, really? You just literally you take the mouse and you just move it and go, oh, that's how you use it. So what do you mean? Then she shows me, yeah, I was trying to move it. Okay, so that's a good analogy when you have an LLM, you can think that it's an extremely smart agent, but it's dumb. It doesn't know anything about the context of what you're asking. You as a person, you have years to develop that contextual information needed to perform simple tasks. So here it's really important to teach the agent exactly what you mean. So when we say, show me something funny, it might be very easy for you as an editor because that's what you do every day to understand that the user is asking for a list of personalized recommendations of funny movies. The LLM does not know it. So what you do, you just give explanations. When you use the mouse, you put it on the table. You don't hold it in your hand. You have to tell the LLM to do that. Realistically, actually, nowadays, you no longer actually have to do that on your own. You can ask the agent to teach its own how to actually do it. But you need to realize what the problem is. You don't have to solve it. You just need to tell the agent, you can't understand what that means. So try to figure out a way to actually handle it. Because if you ask how you use a mouse, the agent would know. But if you don't hint that that's a problem, you need to identify the problem for the LLM. And then the LLM can actually write its own prompt. I no longer write my own prompts anymore. I just tell the agent to write its own prompts. But you need to inform what the problem is. So the thing is, examples are fundamental. This is probably, if you are working with LLMs, you already know this. And this is just plain good reasoning when it comes to building agents. The better agent has a better prompt. So in closing, 3 things that I would like to highlight as reminders, and hopefully, beside the story of my mom just trying to use mouse, you'll remember in the future. First one, LLM needs a grounded brain. That's a fundamental part. LLM itself might sound like it's extremely smart. It's deceiving. It's the imposter in the room. It will tell you something you believe. Well, it's not the truth. So you need to ground it. And UX Engine, as other CMSs and so on, but obviously I'm going to talk about UX Engine, can provide that grounding information about the user context and the item context. Everything else is pretty much today a choice. SCT, TTS, LLMs, there are so many choices out there. And this really depends on how much you want to spend, how much you want to invest upfront in developing, how much time you need to get it to market. So those are all considered.